Hello everyone, this is the fifth video regarding the finite element analysis and design of the piezoelectric based ultrasonic transducers, which is used for cleaning. I defined the steps, now I go to the interactions. Okay, in the interaction, first we have to define two different kind of contacts. The first one is with friction, which is between almost all of the components. It has the friction coefficient of like 0.3, 0.4, and also the normal contact without separation after contact, and also we need the other one, which is no friction, and it has a tangential, which is a frictionless, and also normal, which is hard contact without separation after contact. Why do I need these two? Let me explain this to you. I will remove some of the cells for you to see how does this thing work. I need the front mass to be added. Okay, that's good. You see here, the bolt is in contact with the front mass in this area, and also in contact with back mass or back drive in this area, and also it's not in contact with the other parts. All parts has to be in contact with each other with friction and with normal force. But these two parts, which means the surfaces of front drive and the bolt, which is the surface of the bolt which is in contact with front drive, should be tied together, which means that they have the same degrees of freedom. They have to go with each other. So they do not have simple contact, so they have to be tied. And also the bolts and back drive should not have friction, and this contact will be defined as no friction. So the other parts will be defined as friction. The back mass or back drive and bolt is no friction, and let's see how I define it. So I create in the initial step, I create a general contact standard, continue. All contacts should have friction except two of them. One of them is I want to exclude two surfaces, the front drive and the bolt front drive. These two should not have a general contact at all, so I exclude it here. And then you have to know that the back drive and the bolt back drive should have no friction properties. So all of the others have friction. The back drive does not have friction, and the tie one was excluded. Okay, so we define this kind of contact. We only need to define the tie between the surface of front drive, as highlighted here, and the surface of bolt front drive, which is here. So these two are tied together. Next, we go to the load. Okay, I need to remove all parts except, for example, piezoelectric 1. Okay, now I have to define the zero electric voltage on that. It can be in the initial part. Again, I made a mistake. The electric potential. So I select all of the surfaces of this piezoelectric, and I need the electric voltage or the electric potential to be 0. Then I hide this piezoelectric 1 and add piezoelectric 2. I do the same electric potential, and let me select all the surfaces. The magnitude of this one is going to be 0. And then I have to define the bolt load in the bolt load step. So I remove all parts except bolt, and I also remove these two parts because I want to apply the bolt load on this surface, which is at the middle, almost at the middle of the bolt. So I create the load, I go to the bolt to reload step, define the bolt load, continue. It says the interior surface of the bolt load. This is the interior surface, both of them. Okay, and then okay, you choose the brown one and select the axis, and then the magnitude I assume to be 10 kilonewton. Okay, and then you have everything ready in the load part. We already meshed the whole structure, as you see, and everything is finished. We can create a job here. We define this as ultrasonic cleaner. Okay, you can use parallelization if you have multiple processes. I have 4, and I want to use like 95% of my memory without increasing. Now, okay, so you define the job and then you submit it. That's enough for now. In the next video I'm going to show you the results. Thank you for watching.